So we've been running these Inkbird controllers for I think it's a little over a week now. They seem to be working okay. One thing that's different about them, we'll talk about the boiler control one first. So the way this thing works now is we're running it in on-off mode because PID mode doesn't really work for a coal boiler. I mean, whatever algorithm they have running in the background is really looking to tightly control the temperature by pulsing the heat source on and off, which does not work for a coal boiler. I was expecting to try and get it to, as it's coming up to operating temperature, I was hoping it would anticipate about 10 degrees before it reached it from, going on its previous, runs, that it would start shutting down about 10 degrees before you hit it so it wouldn't overrun. But it doesn't seem to do that. It doesn't seem to understand that it needs to shut down or start shutting down 10 degrees before you get to your set point to avoid overrunning. So we just run it in on-off mode now. But this does not work like a typical aquastat. Like I was running a single Honeywell aquastat in there before. We'll see what it is. I think it's a 606 single aquastat. Oh, sorry, 4006A is what it is. That's what we were running on it. That's this little guy here, and this was set at 160. So I ran this at 140 for a while and played with it. Now I have it set at 150. Actually, you should be able to see that if we hit this. Oh, sorry, 145 is what I have it set at. But the way it works is it has a hysteresis setting, and that's really what you use for the differential. So it's set at 145, but really it's not the same thing as if you use the 4006 Honeywell and set that at 145. Because what that would do is, once the boiler temperature fell to 145, it would run the stoker until the boiler temperature hit 155. What this does is the set point is more of the center of that. So I have the hysteresis set at 5 degrees right now for this boiler control. So what it will do is when the temperature reaches 140, it will run the stoker until the boiler temperature reaches 150. So it's a little different than running an aquastat, but hey, it works. The ashing control, I run that at 1 degree hysteresis, and that's pretty interesting. This actually keeps the ash temperature tighter than the anthrostat. It reacts a lot faster. So the anthrostat seemed to take several minutes for it to react to the ash temperature actually hitting the set point. Like it would just keep ashing until you were 10 degrees over the set point, and then it would stop. This seems to work much better at that. So we're going to see how it all worked out. Oh, one other thing. The third one of these things that I bought, and I mistakenly bought it, but I figured, what the heck, I'll use it as a temperature probe. So One of the mistakes about buying this one is that it is a degrees centigrade only. So I have to convert it. Let's see, what is this? This is an ITC 100 RH. So that is not what you want to use for boiler control. But the strange thing is it has a K thermocouple on it, and I have it set for a K thermocouple, and the thermocouple is right in the stack here. This is where my barbecue thermometer is, so essentially they're in the same place, but... And luckily my barbecue thermometer has a degrees centigrade scale, but man, they read way off from each other, so not sure what to make of that. And just for reference, we're using the ashing control is a ITC 106RH, which has an internal mechanical relay. Just beware of that. And this one here is, tape out of the way here, tape fell off. This one's ITC 106VH. So this has a 12 volt DC output when it activates, and the 12 volt DC output activates the solid state relay. It works just like any other relay. You could put a 12 volt mechanical relay in here and it wouldn't know the difference. This would be where the coil would connect to 12 volts. This would be your switch on off. So when this thing, when this control activates, you get 12 volts here, and this becomes a short. So this activates our motor and other controls in this system. But it's pretty neat. It all is working pretty well, actually. So I'm happy about it. Ooh, let's take a look at the ash. Haven't looked at any of the ash from this thing yet. Well, looks pretty good. That is a full week's worth there. We're there's a bunch of pea coal in there now, so we do get some unburnt bits. Well, that's not good. I guess we'll have to keep a closer eye on that. I mean, mostly it looks okay. It's got some clinkers in it and stuff, but it is not winter anymore. And that's the problem when it's not winter anymore and the boiler just runs for domestic hot water. It idles a lot, so you get partly burnt coal in the ash pan when it idles a lot. So that's probably the cause of that.